up in order to start the online streaming. Thank you very much for having me today. I have to admit that I was delighted when I was invited. And when I asked Isabel and the team exactly what the aerospace talks are, they were very nice because they say this is a way to motivate and also get inspiration about something that is amazing. Yeah. So, and my best reward today will be that in the next hour you find something useful for you, maybe something that it is new, or maybe also a kind of refreshment about what you have learned, what you have done. Definitely something positive, something good, and again, following the spirit of the aerospace talks to really inspirate, to get something out of. So in the next 55 minutes, I would like to make a small, I would say, introduction. How is possible that a Spanish woman coming from Sevilla is landing today, this afternoon, in Stuttgart, in the university, to give you some feeling about aerospace topics, and in this case, the topic of the talk, which is laser communication terminals in orbit operations. Then we will go for my, and I feel very proud of them, team in Backnang, in TESAT. I managed to get a picture of all of them. You will see it. Also, the laser communication concept. If I start to talk about basically how you operate it, but we maybe don't have clear how you really put information in a photon, maybe this also can be a little bit tricky for all of you. Therefore, we will go also, but briefly, don't worry, it's not, I have other more interesting subjects. Then we will go through TESAT actually projects, and also basically to give you the feeling and to build the bridge between what I think it is super important is done in the university, and later on in the industrial environment is further continued or even combine efforts. And a little bit of outlook. So what I think it is not science fictions, but really coming. And of course, time for questions and answers. So I will start with my beautiful city, Sevilla. Actually, when I thought a little bit to introduce myself, I could go through a CV. I could tell you that, yeah, all the achievements, but life and things are not done just of these good things that you finish, but also because of many times that you failed, many times that you were not able to follow the path that you thought you should follow. And then you have to adjust and learn and continue. And actually, this happened to me. I just show you another picture of the city. This is the first one was the, let's say, the old part, and now, well, I have a flight, and then the other one is the is um, I my dream was always to be a pilot, and then when I was close to the exams, I proposed to my parents that I wanted to be a pilot, and actually I wanted to be a military pilot. Top Gun is also quite responsible about it. And my shock, my surprise was that actually my father say that this was not the plan that he has for me. And he was thinking like I could work in a closed shop there and then be with them until maybe I marry or something like that. But to study for what? Wow. To me, this was like, but of course they are human, no? They wanted the best for us, and now also myself a mother. But of course they have fears, they have things that they have also to handle. And for him was also the problem of financial situation, also like they could not afford this. So with this shock, I made the Abitua, I passed the exams and so on. And then this summer I worked hard and I got money to pay an academy to prepare myself to go for the exams. So imagine for me was like nearly 6 months, you nearly don't speak with them because of what they told me. It's a lot of changes, it's difficult, yeah? And I studied 1 year. Physics, mathematics, chemistry, and English, very intensive. Wow, I even didn't go out the weekends. I will pass, I will be a super pilot. And this is in Spain, it's done that they get the best 100, 200, they make a cut. The year that I was applying for the exam, there was more than 3,000 people, and only the first 100 will pass. But I was convinced. Yeah, so I went to Madrid. I did my exam, and I failed. I didn't pass. I didn't get between the first 100. It took me nearly 1 week to come back home and then say, to listen. I told you, this is how it's supposed to, I knew it. But then I decided that if I cannot fly, I will learn everything about it. And then I decided to study physics. And of course, I was also living the life because I was 17 years old and I love it to make sports and to go back and forth. And even I find a job, not very close to the house, but, to a little bit far away in a travel agency. So my life was every day from 9 to 2, you work in the travel agency, you go into the university in the afternoon. And then I was at this time playing water polo in a first division women team. There was not many at this point of time. We are talking about more than 30 years. So you can imagine that it was easy to go to Barcelona, Madrid, everything, no? So there was a point where I didn't know what to do. I'm not improving in the agency. I'm not also going there. So I decided to go to England because for what my friends and colleagues told me around it, they have the opportunity to go in the lab, to really experience, to really feel what it is, be a physicist. And I did it. And I came in the Kingston upon Hull to make my master thesis. I focused on laser and photonics. And later on, I tried to make something a little bit different towards to liquid crystal devices that it was, by the way, quite chic at this point of time. Now it's not anymore. Everybody has a flat screen and so on at home. But at this point of time, it was not so amazing. And my huge surprise is that the university that I choose, it was also the city where Amy Johnson, the first British pilot flying in solo. So she was a pioneer, and she was definitely a woman that make a mark in the moment. And it was just a coincidence, but I thought, okay, very interesting. And the story continuing, because after finishing this, I decided to come into Germany. After 2 years, basically, with the weather and the food, and coming from Spain, I thought, yeah, enough. So I will go to Germany to try to see if the sun is shining more often and if I can get a different type of food. Yeah. So yes, stomach was making the decisions for me, not. No, but the networking at this point of time, and this is also maybe a message towards to the students and so on. I mean, we didn't have social media at this, but it is clear that everybody was talking about. I mean, in the faculties, and as soon as you're going outside to England, for example, my for the master thesis, my supervisor was German, and talking about what you wanted to do. He also told me that why not? I mean, Germany is a very powerful, has a lot of industry. You can find a very good combinations. So then this moved the role, and then I landed in Technische Universität Kaiserslautern, with the professor Burkhard Hillebrand, and then I make the PhD in magnetism. So I was adding subjects, not because I I was bored, it's because I found it fascinating, and the fact that I could work also in clean room and make tunnel junctions and work with lithography and electron beam deposition. So this was a world that I could not really imagine that exists. So after finishing, I thought another decision to be made. Shall I stay in Germany after 4 years? Or shall I go? And the situation was a little bit shocking because I didn't know if I really wanted to stay in Germany. I was feeling cold and not the weather, but I would say welcome from the people in the sense of I was not really integrated. Yeah, and then I met my husband, and then things started to become more easy. And then I decided to, okay, then I will look for a job. And looking for jobs after the university, this is a very nice picture. Sorry, I forgot it, that I have it from Kaiserslautern, from the University of Kaiserslautern. And then I was briefly in Karlsheiß over Kochen. But the big difference went towards to TESAT. I found in one of my super magazines, Avion Renew in Spain, where you could see every aviation development, even military and so on. Very interesting, beautiful. TESAT Spacecom, making laser communication terminals. I say, okay, should be a sign that I didn't fly, okay, but then I went for laser and photonics. Then magnetism to also doing stroboscopic measurements and a lot of things related with light. Okay, I apply, and I would say lucky. I think the lucky was very high, because in Oberkochen, 300 external consultants were fired in basically 1 week. It was the big crisis, financial crisis, 2007. And then you find in a place where you have 300 potential candidates around Oberkochen, where I could go for your position. So definitely lucky, or maybe somebody was helping. And then I landed in TESAT. So, and today I have the opportunity to tell you about the story, but I hope you follow the path related to aviation, related to finding women in pioneer positions, and also the fact of space. So now TESAT has been my second house for the past 18 years. If I think about how many hours you spent working, yes, it's my second house. Actually, it is bigger than my house. But I can tell you that it is a very wonderful location. It is in the middle of Backnang. The moor, the river, is passing by. And you have a combination between old houses, and there is a lot of restaurants to have lunch. You remember, I came from England to Germany looking for better food. And TESAT in the past 18 years, as I was there, has been really constant also in the number of employees, and this is 1,100. I mean, the portfolio is really amazing. We will go a little bit afterwards. And the equipment and the reputation that TESAT has, it is really, I would say, made in Germany. With all that this means, it is really powerful. And I will briefly go through our management, of course. I think they deserve to be also presented. We have our CEO, Dr. Caroline. She actually joined us last year. And the team has, the full first line has also a strong reorganization in the past. I think you also, maybe, I don't know, some professors know some people here, because we have in our first line also former students from this university, this faculty. So the main 4 fields of TESAT. telecommunication, navigation, Earth observation, and science. And really, really deep in each one. You can find components of TESAT in every single field that nearly any mission flying. Customers, we have, I would say, huge palette. This is also something that I learned since a long time ago, that the number of customers has only been increasing. That means that TESAT create a value and retain this value, which is also essential in the current concurrence moment, where the loyalty and the continuity with the products that we are deployment is this essential. We have national other companies, but also agencies like Deutsche Luft- und Raumfahrt, ESA, and also Canada, JAXA, so all over the world. A little bit of history, because I think it's always also important, about TESAT, and it had changed many times, the name, but the philosophy the philosophy and the core themes has stayed. And this is also something that shows the continuity in what they initiated and will continue, of course, adding new people. Recently, a colleague retired, and actually he had business cards from AEG. So that's at this point of time, he has been belonging to TESAT and working for TESAT. This is also quite, I would say, amused in nowadays, because people think that every 2 years you have to change the positions. I'm sorry, I'm not agree with this thought, because when you wanted to bring really something to be finished, to be accomplished, you have to invest a little more of time. In 2 years, the first one, basically, you don't know where you are. The second one, hey, you are starting to be in control and maybe make decisions that it could really bring you forward. And then you are going to change. But okay, this is a personal opinion. There has been huge events that TESAT, as a small company, has also faced a lot of the time. And for me, or for us, one of the most important, it was in 2014, when the first Copernicus satellite, Sentinel-1, was launched. And you will see in a little bit, or not so in a little bit, but yes, soon, why it's important. And then, of course, also, we need to continue to the latest and the last topic. So in 2021, actually, TESAT deployed the smallest laser com in the world. You could put it in your hand, 400 grams, beautiful, the QPLCT. This was developed in combination with IKN, and basically they did the design, and TESAT was the partner for industrialization. We should not, and this is also talking about cooperations, we should not underestimate the power of having the university with a lot of flexibility, or more flexibility, that a company, as soon as you try to do mass production, is facing. So this sweet spot, it is really, really a very successful story, how it was the QPLCT. And then all over, I will not keep you longer, but basically tell you that this year, Kepler has deployed the biggest constellation with laser communication terminals in the world. And this is all produced from TESAT, and they did last year a very successful commissioning from the units, that this is the topic. I'm trying just to bring everybody on board. So follow the line, first from where I come in, then TESAT, and slowly we will be moving also to my team. For achieving all of this, there is something which I think is the vision from our management, CTOs, and they saw clearly that basically the output on production, it has to be increased, because once that we have been in this story making the demonstration of the technology, the goal at the end of the day, we are a company, so you need to make business, you need to make money. And this is a clever vision in this sense, enable this type of activities. And this is also the reason that TESAT even built a new building complete. So this is the reason that we have that we need another logo, because actually this was a parking slot, and you could see the logo here on the background of TESAT, and then of course having a huge building in the front, this is gone. But this building enable us to have the opportunity, because each floor it is a serial production for different topics, different models, and combine everything in one building. So from the beginning, testing and output, you have everything there. This reduces the cost of transporting. I mean, you don't have the hours, you don't have the to move the stuff around. Then also improve the communication, because you have everything there. You don't have to wait that somebody deliver you something and so on and so on. And these are the type of decisions that enable companies to actually be so alone there and have and keep the people working for them. The volume that the company is expecting, I have also a small slide about it, but it is like we will be able, for laser communication terminals, they hope to topic today, to have 5 laser communication terminals per week, fully tested, ready to be delivered. These are the main blocks of what we call it one-stop shop. The idea it is that when you deliver the hardware, the story is not finished. For space business, this will be flying, and basically you will not see this again. So you have to enable the customer to use the hardware at the performance as they expected, but also everything around. When you develop new technologies, this is not like a plug and play wash machine. You put it there, and then you have the water, you have the electricity, everything's running. No, this is also, every mission has their own needs and own characteristics. So you have to keep in mind that you deliver a product that is something that for the company has a cost. You also have to get the flexibility to enable them to go for the full end-to-end system. And this is exactly what we try offering, from components to the equipment, individual payloads complete. So this is the full assembling and the full testing and everything for the payload. And of course, the service on the top. I just go very brief there just to give you the feeling about in the 4 main areas that I was mentioning at the beginning, how many products also you have, because it's not only basically for one scenario or for one application. We have different, for example, in the system and passive solutions, the portfolio is huge from payloads and subsystems, which are the most, let's say, biggest ones, to switches, for example. And the same for the optical communication and quantum solutions is the same concept. You have currently 4 products available for different scenarios, for different needs from the customer, from the different missions. And the same with digital solution. And you will see also slowly how important this is, because the way of make communication is changing in space. This is regarding solutions, and coming back to the concept of the end-to-end system. When the customer come in for the mission, it's not only that want something particular that is a puzzle and you have to put in. They wanted that you basically solve the problem to transfer data from A to B. And that this is including data routing, including everything that you could think about it, because they have to define the ground segment. They have to give requirements for the ground segment. And all of this is happening typically, I mean, in traditional space, this could be even 8 years before. But in the new space, next space, as it's also called, this is maybe a matter of 1 year. And this is a huge effort that a machine like a company which have serial production that have to absorb and go for. But not only, let's say, for equipment and so on, also for the mindset of the people. And also very important, data governance. Yeah, this is with AI now flying all over. These are the things that are structuring and the difference between successful or not successful. These are missions. This is an overview of the missions that currently are going to be before and after, like a Hydron. Yeah, so Hydron, it is the next optical network for Europe. OpStar, sorry, it is also in the same concept and towards to Galileo communications. Networks, this we will see, I have also a slide about it, how this really means and work and for really companies that are aiming to get service out. I mean, if we think about it, right now, what you cannot even pay in a petrol station without a satellite. So it's nearly everything that you do has a point where you go into the space, and the latency and how you are able to control this, it is making again the difference between having a running and good business or not. Here is what I spoke before also. It is more focused towards to partnership. When the time is changing so fast and you need to adjust yourself, you need to gain flexibility. And this is also done with outsourcing. So collaborations with institutions, with other companies, small, big companies around, depending on the mission and the type. These 4 blocks are really, I would say, important for TESAT, and we are very focused in nowadays to be able to continue with that. So from KUKADE to digital payloads, next generation RF technology, or industrialization. As I mentioned before, we have new buildings. It's really high tech, but this has been implemented. But the business, the operations business is also a challenge, and how this is internally controlled, and also how you prepare your teams. Because and the people, again, the university, what you are doing right now, I have been sitting down there also, as you have been, and there is sometimes you say, okay, for what is this useful or not useful? Why I'm wasting my time to not learning maybe something that I think is useful? But no, there is a combination, and this is an effort that teachers, I mean, academic environment has also to do in order to match and combine the needs that also the industry in this sense have. Because when we finish, it should not happen like it happened to me, that I don't know what I'm going to do. You need to have a perspective, and in the universities, one of the places where I think we can create this perspective, but in good combination with the industry. So now we are coming. I hope you are warming up. I hope that you are getting what we are, because now I think is where I start the really most the topic. So keep this picture in mind. Okay, this is basically you have for every level, TESAT has a solution. And the challenge here, it is also to connect every of these layers to be able to do the job. And we have seen it also recently, unfortunately, with Ukraine situation, and also any time that internet is not available. So, I mean, you have to find ways to become safe, to have the best options for the citizens. And to me, this is one also of the topics that TESAT make the beauty of TESAT. TESAT works for doing the world also better, and at least the people that work there. So I have a son, actually he's here also today, but basically we wanted to do to connect in the space, but to make it that the world around is better. I am honestly, my personal opinion, this is not TESAT opinion, my personal opinion is that I'm very sad to see so many negative, so many things around. I like to think in the future, and I like to think in that I'm contributing to this future. Because I think if all of us do it, this is the way that things can, yeah, work better. I mean, individually, we don't manage anything, not even, yeah. Anyway, they leave it there. But yeah, this is, now this brings me to a topic, my team. Please allow me that I have make this small game of words between German and English. They are laughing because they know this, they are here. Toll ein andere Macht. Yeah, it doesn't work like that. And I know that there is a lot of competition. I know that everybody has, or a lot of people has their own agenda, but I truly believe that working together is the only way to bring things forward. And the technology itself is so complicated that we also make it with the relation and between us and so on, so difficult, no way to go. Therefore, I always try to push together everybody achieve more. And this is the reason that I have the pleasure to introduce my team. In 2015, TESAT, after being also struggling because the volume of work became immense since some of the programs were running, took the decision, to create a unit, yes, a team that it will be taking care of accompanying the customer from the full process. Yeah, and the first challenge that we figured out, as is also happening today for AI, it was to define the roles that are needed. So we wanted to tell to the satellite what they have to do. We wanted to analyze everything that they put down, that they flash down, and yeah. So, and in this sense, I'm working, of course, with institutions, GSOC, Nobel Pfaffenhofen. We also were with IKN in contact. The DLR, the agency was also supporting us. ESA was also very, very involved in guide also companies to actually make this jump. And we created a team that basically it is fully autonomous in the sense of we have project managers. Actually, I have to say that Tom is here. Tom was yesterday in the hospital, okay? So I highly appreciated, Tom, that you came today. Kai, Esther, there are the three of them here, also from the legal department. I have Kwetka. The point is that they are young. I'm the oldest one. They are young and they are in the position to learn also on doing and to bring the things. We also make a struggle a lot because sometimes we don't know how to solve, but they need to keep the calm because for us it's also a little bit like, you know, Apollo 13, no? So when they say, Houston, we have a problem. Yeah, they call you because we have help desk. And then they basically, they are very upset because something is not working. They have the pressure that the things, you know, you are losing money. What's going on? We don't see the light. Okay, why? And they have to keep the calm. They have to work, find a solution, and in a relative short time, give an answer. This is not an easy task. And by the way, everything in English because, yeah, in Germany, of course, internally we can work German, but as soon as you try to talk to Viasat or Eutelsat, or everybody's speaking English, so they have an extra push there. In this process of creating the team and also thinking in how to serve the customer best, we also identify which are how we can do it, no? What they needed, So you have in the field of the laser communication terminals, you have a new technology that actually is not really complicated, but it's new. So if you compare with RF, which is more that, I don't know, 30 years is stable, and you have this, here, no. And actually, there is a lot of customers that they get for the first time a laser communication terminal. And as I say, it's not plug and play 100%. We are working to make it more simple, but this is a process. So we identify roles like, of course, CONOPS, definition of operations, requirements I mentioned before. You also have to think about how it will be the software monitoring your terminal, how it is going to be, how is the bandwidth that you need in order to download all of this telemetry. There's challenge that, okay, I mean, the control center, the mission control center, or the spacecraft control center is one of the latest in the queue. Typically, this works that the primes, the ones building the satellite, buy the equipment. And then the mission control center or the spacecraft control center has to deal with that. So to bring everybody from the beginning, enable that the mission will go on time, on cost, and on quality. So this is very important towards to the engineering consulting. But of course, we also realize it that if the customer is new, they need training. And they need training for operators, they need training for the system engineers, so that they will be there later on also doing the first analysis of the topics, and also to analyze the impact of the laser communication terminals in their satellites. For example, another important or core activity that the team has, it is to accompany the exercise to verify in orbit the performance, but later on also to check the evolution, to tune parameters, to change and modify things that it could ensure that you really have a mission for the time that you request, or actually if you face problems that you didn't think it would be there, radiation. For example, we also knew, unfortunately, some thrusters were leaking fuel, and then yeah, this is a chaotic situation. Everybody there was on panic. You need to face that, solve it. So this is the task that the team are focusing, and these are the roles that we also have. The latest will be the help desk. Help desk, when we are naming help desk, you know, when you, for example, I mean, Vodafone or any others is not working, or you have a telephone, you call, and then typically you have somebody that is giving you, yeah, what is the problem? I will take note, I will pass the ticket. This is the first line. But then we build it that actually the first line is also the second line. So basically, a control center or a spacecraft control center will contact directly with the engineer and actually will ask the questions directly. I see this telemetry, I have this problem, how can I solve it? And inside of basically three working hours, we will give a first assessment, and then as soon as we can, with a maximum, of course, of time, depending on the mission, we will also be able to give, hopefully, work around that the customer can enjoy the performance of the terminal. Say that. Somebody asked also wondering how you put information in photons. I mean, I hope there is not many professors, because I I don't have that, but I have one slide that I think it could help you to understand it. Don't go and panic. I mean, if it's not the point. So I will go to talk about you have a pocket lamp, yeah. So you have a and then basically you do like a Morse. With that, you will have a type of modulation that is called on-off key. So basically, there what you control is intensity of the light. You have light, you don't have light. This is your 0, this is your 1. Then the other one, it is the binary phase shift key, which is a little bit more complicated, because you basically need another laser, a local oscillator, that it will be the exercise to actually lock in phase. But the same here, you will have a very clear stage, which is in this case is determined because of the phase of the wave of the signal, zeros or 180. And you are able to see, so for example, here I mark it you see my mouse? No, you don't see the mouse. Basically, the first block on the bottom, the first block, it is showing you the signal on the belly. And then on the second one, it is showing the signal, it is already in the ramping up. So it is a very stable way to also lock your physical layer, your light. And this is more or less, I don't know, I mean, maybe yes, you still use sometimes FM radio, no? So like to turn this. So when you are looking for the signal of your radio sender and you lock in, yeah, perfect, clean. You hear it. This is this. Okay, similitude. It's not the same, but you can make a very good picture about how this works. So either you have that most code, or you have the opportunity to actually select your frequency, and then basically to lock there, and then the signal, it is much better. I think this is enough for basically understand the major concepts that make things a little bit more challenging, because BSPK is something that it is you need high technology. You need also to become it's a little bit more complicated in the sense of building the equipment. On-off key is something which is more open and wide use it. So say that. Now I'm going to give you a kind of feeling. Yeah. So basically, I am a very physical person. I always need to have, some image, something that help me. And RF, so carbon antenna, for example, if you have a geo satellite, the spot beam, it is approximately 250 kilometers. No, you have the geo is 36 1,000 kilometers over the surface of the Earth, and this is more or less how it will be. No, so now you come into using laser in a geo. And I think you can see, you recognize this location, no? So I also try to to make it you see that you can think about it when you are sitting in the building later on. Say, okay, how will be the laser? So basically, for a geo laser spot, it is 800 meters from 36,000 kilometers. But now, if you think about a LEO, wow, this is really like you try to reach a window in Barcelona from here, yeah, sitting in a car which is driving 25,000 kilometers per hour. Easy, huh? Yeah. So this is how we do it. It is fantastic, honestly. The technology itself, I can only say that I'm a passion with Pioneer. So definitely, this is amazing how the laser communication terminals work. And now that you know where we are, so a little bit to put you in location, I would like to show you. I mean, this is of course a simulation. I don't have anything from space, unfortunately. We are working on that. Maybe somebody can put a camera and we can see how things works. But in this case, it would be infrared. But okay, so let's see if it's working. There's no sounds. So here you see clearly one of the terminals is started. So this is the screen on the right side. So one is starting to actually do spiralings towards to the counter terminal. Then the other one started also. So you stop and then you start the other one start. And then you're reducing your uncertainty cone. So basically the spiraling concept. And then you lock your physical layer, your channel, your optical channel. And TESAT is working currently with all the standards, because this is also something that you have to think about it. As much standards products you can have, you reduce the cost, you make it easier, you are able to predict what you have. So this belongs part to the development. If you put products or things or the technology itself is not really, I would say, reproducible with the frequency that you needed, yeah, then it's a little bit a bottleneck for developing a business. So this was for the movie, and now I have also. I was talking previously without introduction of Geo, MEOs, or LEOs, and this is only just to give you also a feeling. I mean, these are figures that you can easily keep in mind about how laser communication terminals work and what they have. So basically, when you try to build what I mentioned before, this transition that you are more focused on networks in space, you have to cover nearly every orbit. I mean, right now we know, no, so everybody here space debris, everybody here a lot of things, but at the end of the day, I mean, because probably you know even better than me, okay? So I will not go in this field to try to explain you anything, but the concept from the business is really that you have it on LEO, so 1,000 kilometers maximum over the surface, then you go into MEO, and then you go into the GEOs. And the capabilities of each of them, as you could imagine, is also different, and the visibility and the way that they are commanded and monitored. So these are the key satellite orbital parameters. To me, for us, GEO, it has been one of our major, I would say, horse, if I may, because it is really a way where you have 24 hours availability, and you can do many things from the point of view of monitoring, also to commanding, to have experimentation, to have many things related to that. This is a small animation. So this is the idea about how constellations could work, and this is also the trend that it is right now. Working more. I mean, as I mentioned before, Kepler already launched many. I mean, Starlink, I think everybody knows this also. So basically, the company is for communication and really focus on deploy constellations. How we are doing? It's okay? Are you tired? Shall we leave already? Or no? Okay. Thank you. What do you need in order to make? I mean, when the customer come in, and then of course it's the first LaserCom. You have a lot of engineers sitting down there. Everybody knows better, and they sometimes even are not listening. Yeah, but it's now since 2013. I'm coming nearly with every customer that TESAT has related to LaserCom, and I have seen the evolution also. Yeah, so basically, in a very simple way, you need the sequence of commandos that make that the link take place as expected. You need to have your T0. Remember, you need always to have two terminals. So you need to have the sequence, it has to work. Yeah, so it cannot be that the let's say spacecraft interface together with the LCD interface, it has to be really working. And it has to enable you not to have funny, I don't know, timeouts of the satellite or whatever included that make that the operations are not happening. The link planning, this is a huge challenge because you have to deconflict every operation of the other payloads or of the other antennas, or even avoidance, so a collision avoidance maneuver. So for the LEO satellite, this is something that maybe if they are lucky, they do it once per week. If they are not lucky, they even are facing 4 times per week. So you are changing the position of your satellite also, inside, of course, of a box and all, but, this is something that when you have to go point to point with a laser, it can be a problem. And this is really important that the customer think about having a stable and good link planning to coordinate both terminals to be on time, on the right place. Operational products. This is what I mentioned before. When you try to make constellations, typically they need to talk to each other. So they also have to be in the position that they are able to exchange the product, the operational product, which is no more that these commando files that I mentioned before, and also the terminals always give you feedback about what is happening. So either normal progress, or well, we have a problem, or I have a problem but I can continue. Please check. Yeah, so it is really an intelligent device that is giving you the feeling. So you have to monitorize this, and this is what you also have included in these operational products. And you also need a system. And we are very lucky because actually with the GEO, with Alphasat, we were able to have access to what is the I4S, which is a quasi real-time monitoring tool. So I think about it and my hair is going here. I was able to see the first, well, you see via the telemetry, but you command the movement of your CPA, so of the optical head that is moving on the satellite, and you can see the movement and the displacement and everything because the telemetry is provided to you. Maximum delay in 3 seconds, but this is nearly insignificant to the pleasure to be able to see how things are happening. Moreover, you also are able to read the sensor, so you exactly know the intensity of light that is coming to your other terminal, which is brutal. Yeah. Moreover, if you try to do space ground links, if you have this option, this is also something essential. Okay, so you say to the customer, yes, this is what you need, and yeah, so timeline, how do you do this? The beauty of the laser communication terminals is also that they can be used as a measurement device for other items, because it is able to, for example, if you wanted to characterize the radiator and you wanted to characterize any other unit that you have, how it is the vibration of your satellite when you are doing solar arrays rewarding the sun. So everything that you have around the terminal is actually so sensitive for that. And also like the timing, when you deploy in the Leo phase and so on, in the Leo phase, you also need to think about it, that the longest that you have your commissioning, you cannot start in the nominal service and the operations. So the target it is to have it such that you do it in the minimum time necessary, that you can come into your routine operations as soon as possible. For missions where you deploy a new demonstrator, you also wanted to test and do many things with that to see if you can play, what you can learn. And when you are working also with space ground links, the characterization of the atmosphere of the optical channel, this is also a side, I would say, a possibility to research with the laser communication terminals. And this is the reason that we typically has these 4 main blocks. The idea is also that the customer has a learning curve. They have to also be able to evaluate it, what is the impact in their systems, and also see how it is good, the deployment. For example, the Earth observation, the Copernicus Program, they were making thousands of pictures, and of course the mass memory of the satellites has a limitation. Therefore, the laser communication terminals is a solution for them, because, for example, as soon as you try in commissioning, you have maybe, or in verification, you can use a different bandwidth. But as soon as you come into the nominal operations, you started to maybe deploy 40 terabytes per day. So if you think about it, a one layer DVD, you are talking about 8,500 DVDs in the day. Not bad, huh? If you can have this information on your desktop, yeah. So this is the reason for that. And of course, as I say, the training and enable the teams on ground to comment and to monitorize the terminal. So programs. TDP-1, technological demonstration payload. This program, it is the one that started in 2013. Where we also started to see how it's going to be and which options do we have about it. It has started with one of the LEO satellites from Copernicus, Sentinel-1A, and then as soon as the other ones were deployed, it was Sentinel-2A. And on top, it is the big antenna of Alphasat, is the GEO satellite. It has the LCT-135 from TESAT, a Ka-band antenna, also developed by TESAT, which at this point of time, Ka-band was pioneer. So even RF was not so like for commercial applications. So, but they put it there. So really, really good ambitioned project, and also they get it new how it's called this in Aptronic, making the how is the name? Star Trekkers. Oh, sorry. Oh, Star Trekkers. Yeah. To see where you are, the direction, and so on of where you're pointing, and digital switching matrix. So this has been the only one. So it's very unique because you were able to transfer the carbon information also via the LCT. So you have a device that enables you to transfer the information between both of them. Yeah, and you see also we have the LEOs, so optical link in red. We also have the airborne links that, by the way, was recently also demonstrated in December with the project Ultra Air. And then we also have on the right side bottom the TRGS, the Transportable Adapted Optical Ground Station. On white, and what you see on the bottom is the RF ground segment for the carbon antenna in space. On the left side, on the right side, sorry, there is some of the technical features. 1064 nanometers is the first generation, so the LCD 135. Now we have evolved to different wavelengths, also to make it safer for the eyes, because the 1064 is a class 4 laser, so very powerful. And in order to make it more friendly user, it's coming to the 1550 nanometers. And basically the carbon enabled that the full satellite, it is able to deploy the auxiliary telemetry. This is super fast downlink, which has basically any information necessary. It can be done or flash down. It doesn't need to go in the optical link. So hybrid concept. And the TOES, and if I may, I will also show you a small video about our TOES. Oi, my fault. I wanted to put the voice, the tone a little bit higher. So you see now, here, it is the CPA, the cross-pointing ahead. And this is how it would be in the space. But here we have the opportunity to see it. I don't have, as I say, camera there. Therefore, here we have a second CPA, but it's because we have separated the uplink and downlink, okay? But this is belongs to the design. On the background, you see the Teide. I don't know if you can know Canaria Islands. And on the right side, there is the ESA OGS also. And we are able to operate both of them. So now here are some of the factors, which is what I was, remember the picture that I showed you at the beginning. So in the way that geos are also, this is sitting in a geo, the LCT for Alphasat. This is also more or less behaving like that, but you have it on the space side. This video and this information was also done in the team, of course, together with TESAT, but it was very nice to put for the first time, because it's very unique, the TOES, and enable us to actually use a test bed. We have been supporting projects to have the demo happening, just because the TOES was available. So they are able to deploy a new technology just based on what they can test and learn together with the TOES. Okay. So now we come into a little bit more of figures. Yeah. So since 2013, as I mentioned, you see on the left side bottom. When I'm speaking like that, yes, it's left side bottom. Sorry for that. I thought I was screening. This is where we started, and actually At the beginning, the links were done from the space element to the ESA OGS. This was the first attempts to see. It is 1 meter telescope, so it's really, the conditions are very good for doing things for the first time. Yeah, where you use the maximum power, where you put everything there because you wanted to see the light on the other side. Then we were continued as soon as the Sentinels were deployed. We started also with intersatellite links, and these are the colors that you see here. So until 6 units. And we have got years where also, as it was said, is transportable adaptable underground station. So we transport this there. So it is in one container inside of another container. This is very, very well thought. And actually, for every, even was thinking to be on board of for boat, big transport over the sea. But for different issues that also happened in the past, we at the end was in Tenerife, and we are now in Simmerwald in Switzerland. But the exercise is really that TDP-1, it is available for many ground stations, of course, operating with 1064, BSPK, but they are available for many ground stations that they wanted to deploy and test. So think about it. We are a company, but we are having a test bed that it is enable other companies to go ahead with. And also other demos, like for example, as I say before, the airborne, because the unit was not even developed by TESAT, but this commitment to bring things forward, to have deploy the technology, the knowledge that we have learned also in the meanwhile. This is also what's moving us, and it is giving very good results. The footprint for EDRS as a commercial program. So we are coming now we were in experimentation. We are enabling entities to deploy what they have as a demo technology, software verification. There was many of the softwares because they also need to try and to see how they can compensate issues. But now this was the footprint for what it is. EDRS, so was the European Data Relay Satellite System. And there, the mission, it was designed for really, as I mentioned before, 40 terabytes of data per day. So it is really distributed between 6 Sentinels. At the beginning, we are only 4, and then they have been, as soon as they are progressing in mission, they has been deploying more, but the average of kilometers is 45,000 kilometers. So if you think about it, how fast is moving, how secure, because it is actually the only thing that you can do is break the link. So break the bin, and the information will not go. So anti-jamming. So it's really a way to do it faster and really safe. It doesn't want. Why? This was the latest 2 Sentinels that were deployed, and they were at the end of the year pushing in. So this is the 2 lines that you see here coming. But okay, now we go into commanding and monitoring. Okay, so we have seen hardware. We have seen different type of scenarios where you have experimentation, you have also commercial applications. And at the end of the day, the commanding in general, it is really agnostic for the type of system that you're using. So meaning that it doesn't matter GEO, LEO in this sense, because you will have a container of commandos, you will have to do your link request. So everything, it is equal for all of them. So what it is important, it is that every entity has very clear what they have to change and what. And this is a generic picture. Basically, customers, you could call TESAT in this case, is the customer. We say to the mission control center, so the laser communication terminal mission control center, you don't see the mouse. So basically on the left side, the 2 buildings there. And we tell them when we wanted to have the links. So we wanted to do experimentation links, we have to do nominal links, and we tell them to the mission control center that in this case, for the mission of Alphasat, the DP1, it is GSOC in Oberpfaffenhofen. And then basically they distribute the information, so with the request, to the LEO satellite, Space Control Center, and the Geosatellite Space Control Center, which is BIASat. And they respond with the input, so they also have to exchange position is the orbit, where is the trajectory that is going to be followed, all of this information, because basically the terminals works with Chebyshev's coefficient. So we started to work with a prediction orbit, so we know where we are going to be and which time looking, and then as soon as the lasers are looking, they are continuing together. So this information need to be exchanged. This need to be done, and then we this is executed. And of course, then the data and all the result of doing the link, it has to be also deployed and exchanged. And this is, as I mentioned, this is hybrid. You have a Ka-band antenna, and you have, of course, also the laser between the LEO and the GEO. This is the generic picture. So you also see here basically the data in this case, because of the Sentinels, they are Earth observation satellites. So this is, and now we're going a little bit more deeper. Yeah. So you see the parties now involved, and now how you do it in regular of time. Yeah. So this is a weekly planning. It is a very, I had to apologize for maybe using a relative old paper, but it was so well explained that sometimes, because if old doesn't need that, you need to throw it away. So this is also something that I find, but it's okay. As I say, this is my personal opinion. So basically, 1 week planning system. So 1 week in advance, you have to say where you are. And why this is important, that you also understand how it's done currently and how we propose always to continue. You exchange with the different entities, as I explained before, the needs of information to predict where the terminals need to be pointing. They are called in different names and so on. So basically, you started to preparation from Monday to, I would say, Wednesday, and you have everything ready. When you select your links, I mean, there is the slots link. So it's the area where you have already deconflicted that you are not an antenna, that you are not firing a class 4 laser via half of your satellites. I mean, these things need to be, otherwise you can damage also hardware. And therefore, all of this is there. So you know now the slots, you know where you can do your link, and then you provide now to the both sides the commando files. You tell them exactly what is your uncertainty cone. So how big is your spiraling? How long has to be looking for the other one? When the link start, and of course that the data need to be injected in this physical layer. You remember that we talk about it. So, and then when the link finish, and this information, it has to be exchanged. They have different names, but at the end of the day, on Thursday, you close your planning and you cannot touch anything else. I mean, Esther here also, she knows that she was initially mission planning, and the tension on Thursday, when you're doing many experiments and you need to confirm so many, I would say, thresholds, and that you have got the right value, that you have converted in integer, that you have it in hexadecimal, that what is the, yeah. So there's a lot of responsibility, because the control centers are typically transparent. So when TESAT launched one of these commando files, it's going through. So if we screw up, oh my God. Yeah. So these are the type of things that the team is doing, and this is what happening, the tension and the stress on Thursday. So don't call us. So if you wanted to have some answers to your question, don't call me Thursday afternoon, please, because we are going to be, everybody's now focused on having things running. Then the control center, I mean, the mission center, so GSOC, will do the check-in of everything, and approximately at 12, 13, 14 on Friday, we know that, yes, the planning went through. Yeah. So we are going to have links and things are going to happen. The same thing, less dramatic, of course, because here is, but it's happening with every system nowadays that is doing this. Also with SDA, with NRL, everybody working on the other side, it is doing the same concept. But this is not sustainable. So as soon as you have 300 satellites, wow, how can you do this constantly? It is not possible to do it like that. So we have to go and evolve to a more flexible planning, more flexible commanding, more flexible monitoring, or even I would say agile. You need to react if you think also about space ground links. When you have a cloud coming, you do the link because you cannot really do this right now. So actually you lost the link. And if the mission has been designed that once that they flash the data, they are lost, bad luck. So this is the point that we have been also working close with I would say everybody now involved in Germany or in any location that is using ground stations. We, in this case, working with IKN, talking about the QPLCT that I mentioned before. There is this publication. I just put the reference there. You could have it if you wanted to afterwards, that you can check. But the idea here, it is the concept that we started to work. It was to make it really like even 1 hour before or half an hour before, depending on the quality of the system that you have for predicting your weather, local weather situation, that it has to be, the planning need to go with that. We need to enable that if we have type of disturbance, this has to be, the data has to come in. So, and actually, if you cannot do it with this ground station, you could do it with the next one. And this is the point, that this is site diversity, so that it is a way to solve the problem of the weather. So if we are able to do a flexible planning and be deployed not in OGS 1, but in OGS 2 or 3, then the problem is solved. Of course, then we have the other bottleneck. As soon as you have such amount of information down, the terrestrial network need to also go with this information through. But this is a different challenge that we are not talking today here. So what the idea it is that you have your space segment, and there is a pool of the information that is coming, basically, and interact with your request. What do you need? What is the telemetry that, the amount of data that you wanted to transfer, and all of this information, it was you are deploying there. And the weather information is also there, which enables you to do a agile deconflicting of the link request. And this information, it is basically, they are able, because this is right now with GEO, with LEO, the thing's becoming a little bit more challenged, but with GEO, they are able to change this, and then the data will be not lost, but it will be in the next one that is available for deploying this. What is the beauty of that? The beauty of that is that this, if you introduce direct to Earth, so space ground, and also the talk to feather links bottom up, and you go into a generic link plan system. So the point is that when you are so many cases and so things are not progressing. You need to go towards the standards. You need, from the industry point of view, you need to go to standards. You need to go to more generic things that you can really make it easy for operating, friendly user, we call it, and so on and so on. And this is exactly how they have adjusted the system. So here is only a little bit more, I would say, technical, but the concept is the same. The user make a request. I wanted to have this amount of data from this satellite, and this is submitted here, and the ground segment is also given the availability depending also of the weather information, and then everything is deconflicted with the constraints of the spacecraft, with everything that you need in order to be sure that you are not damaging anything, that the things are happening, and then you get inside of, automatically you get your new link planning. And this is something that enable actually thinking in constellations, because Well, I will tell you later, but I will go now for something else. I was maybe too fast. Nevertheless, it is the idea is that you can or you don't need so much to come into ground, that you slowly are also making autonomous the terminals in the space, meaning that if you can get the same information of the ground station, then you are able to decide without passing through this, I would say, deconflicting link planning in the cloud. You are also able to do it by yourself, autonomously in orbit. And this is the solution for when you have it so many terminals. And actually, if you go and thinking, right now we have an average of 10 minutes with the LEOs, 20 minutes with the GEOs, even 40 minutes depending on them. But if you wanted to do permanent link, if you think about a constellation where you have in a satellite 4 terminals, like a Kepler is deploying, and you have constantly an optical link with your neighbor there, so in plane, cross plane. I mean, beauty, no? This is the way that we should think about focusing on having that and enable this. So this is the reason for working also in improve this type of planning to include this flexibility. And now we come in to monitoring. I mentioned before that GEOS, I mean, you are available 24/7, so this is something that you can really trace. It's not like every 100 minutes you get 10 minutes, or you're lucky, or maybe 3 minutes if you're not so lucky, pass of visibility. And then I wanted to more or less to show you what we see when the optical link is happening, what we see. And you have on the left side, in the epsilon axis, you have the terminal mode, and on the x-axis, you have the time. And basically, the T0 market here, it is the moment where the terminals start, you saw in the video, to do this spiraling and to start. So T0 is the moment that the lasers are starting to operate. Still, you cannot put data in. You have to lock the laser, okay? So this is the next steps. You have spatial acquisition, frequency acquisition, but you see that on the y-axis, you are coming from pointing to spatial acquisition, frequency acquisition, and communication. These are the levels of the modes. Some of them are time takes, some of other ones are depending of what is the exchange between them. It will take a little bit longer or less time, but at the end of the day, you are reaching communication. So the top side of the Y, and then you see in green is market communication. There is where you are injecting data. Until then, it's all preparation. You need to acquire, you need to lock, and then you have it. And of course, is ending. There is some parameters here, but this is, if I may, I wanted to show you also a small video. This is what you are going to see is real the monitoring tool that I mentioned before from Alphasat, and it's really how you see the link happening. So this is happening in space. Of course, now it's not real time, but when we make the recorder, this is exactly what you have. There is also no sound. So this is the situation. This is between Sentinel-1B and Alphasat, so a LEO and a GEO. And actually, we went a little bit faster because, yeah, this is too much to wait. But you have here three main blocks. On the left side, you see you have the fine acquisition sensor. So this is the signal coming on the Alphasat from the Sentinels. And then you have also the tracking sensors, and then the bit error rate correction. So this is more in the data layer. Okay, but the two main blocks, the two on top, are the ones showing us how the laser it is performing, or basically if we are going to go. Here on the right side, you see the terminal mode, and in green, it was also marked if you are now in pointing or in which mode you are. We can go a little bit faster to come into the real link, but nevertheless, you see CPA angles. The CPA is this optical head that you have seen it in the, so it's starting to move. So it's meaning that it's going to go to the position. So it was in part position, then it's starting to move, and then it's going to the position to wait, where you should have the T0 that I explained it before. And This now slowly is starting to, now you are in pointing. So basically you reach your position, you are waiting there. And because here the Alphasat, you always have one that is started. And in the past, we used to say master and slave with the, I would say politically correct. You don't use these things anymore. So you have leader and follower. So the leader start, and it is the Sentinel. And then you see the signal is already starting to be received on the fast sensor of Alphasat. Okay, so we have one starting already. The other one is listening, and this is the signal that you are seeing. Then, as soon as you get in different hits, because there is a sensor, quadra sensor, you need to get enough hits there that you can pass to the level of frequency and spatial acquisition to really lock your laser. So you need to have a minimum. But you see already in the tracking sensor, and maybe I need to explain this, I missed it, but you have one big, well, it's not like that, but okay, big sensor. And then you have approaching to the tracking sensor, which is in the middle, which is 10 microrads. I mean, this is really, really small, but the other ones are guiding that you at the end are concentrating your signal in the middle. Yeah. And this is where the tracking sensor is. And you see here, it is what we were talking about, the PPSK that is starting to look and looking and then going up. And this is when you have on the top line, you see very long, very long, very long, nice, very long signal on the tracking sensor. That is your communication. The communication is happening there. And actually the bit error rate is showing you so small value, so it's 10 to the minus 11. It is showing you that it was flawless and everything is happening. So this is the tools that enable us to verify if Alphasat link was happening as we expect. Actually, if the counter terminal is doing as we expected, because again, Alphasat is the one that has the tools, so you have to measure with them. Okay. What we do with everything, the telemetry that we get, the data that we get. So slowly we have to talk about, I make a little bit of recap, the hardware that you have, the basically the layers that you wanted to solve, no, the solution for transferring information. So we should not forget TESAT is a company that make the main business is communication. And now you are producing a lot of data. Yeah, data without assigned value is nothing. So what we did is that from the very beginning, we started to define what we call it the principal parameters, and this is bringing us to the key performance indicator. So we have currently the opportunity to make what we call a long-term performance analysis for every terminal that we have. So basically, we have the key performance indicators that tell us the status and the performance of the terminals. And if the customer wanted, of course, they are added. If not, then actually we gathered a lot of information. And for the experimentation time with TDP-1, it was really, really useful because this helped us to improve the design, to make this retro information. You get this data, and the engineers learn from what you have executed and what you have, and then they are able to optimize systems. Or in this case, where I was also, the spacecraft can get the trends that also the system it is seeing. For example, the consumption power. In satellites, this is something that is essential. You have a new technology, and of course, you do your prediction, you do the best as you can, but definitely what verify everything is what you do in orbit and how you do it. And this is, for example, just an example of the how stable, by the way, it is the performance of the terminals, and also with the pointing stability. We were thinking about the window in Barcelona, and we are making, a optical link with a window in Barcelona. Think about it, and look how good also after the evolution. This is from the Sentinels, from the first Sentinels that were in orbit, how good it is, how stable it is. So it's constantly pointing and doing the job, doing what it has to be done. So this is also something that is essential for how I'm doing with the time. I'm bad. You should say before. Okay, now I have something very I would say cool, not nerd. Okay, cool. The engineers working there, when we receive the telemetry, and then they were, yeah, we need to know. We do everything that you can, and even the sounds, allow me again make this kind of game, but sounds of space. Yes, I mean when we saw Star Wars and so on, yeah, yeah, we know, no, this is not happening, but this is really sounds of the space. So we have in one of the modes. The terminal, one of the sensors, position sensor from the pointing ahead angles is one of the try to orientate and compensate with this. It is power, but it's not a controlling. It's not doing anything. So it is listening. And some of our colleagues, an engineer, make a conversion with MATLAB script, and then he get it as the sound. It's shocking, huh? It's not clouded, or it sounds like a. There is, of course, some white noise on the background, probably, but this is like what it was happening on the satellite. Yeah, something is there vibrating in this way. It is. I don't know for you, but for me, it was like a. Oh, really? You did it? Oh. Okay, so you see, I'm bad, but not so bad. Okay, now next generations, terminals, lasercom. We cover everything. This maybe is the merit. Heritage is what I show you in detail, or I try to show you in detail, and then we have the terminals coming with 1550, as I say before, but they are fully compatible with everything that is around. Honestly, right now TESAT, it is. No, I don't want it here. These circles basically. Escort 80, already RTL 9. The rest of the terminals are coming, the students designs in running this year, at the end of this year. So Kepler already deploy this huge constellation of lasercom. Airbornes also have been there. So this make us to win last year the hottest company in satellites. Yeah. This is how it looks like. This is Kepler. Yeah, this is on the left side. You see the satellites with the 4 Escort 80 here mounted. You see, and then here this is to bring it inside of the rocket. Yeah, of the satellites, and then on the rocket. And this is where I was towards to the outlook. I mean, traditional satellite communication. It was one-to-one RF. Now we are transient to the really to have combination RF with optics, and basically not only intersatellite link, but uplink, downlink also. And at the end, the satellites are really working as a network. And this is what I was trying to mention also before, to try to bring you this. This is the outlook. This is what is going to be. We have to be in the position to operate this. As I say, traditional on the left, new satellite architecture, and also thinking more if you going for data processing and how the data processing it is. We didn't touch this today. This will be another 90 minutes, and I apologize for taking so long. I thought it would be 1 week. I went 1 hour, sorry. And then basically, I come into where I started the story. I didn't become a pilot, but my family, my friends, everybody knew about my passion for aviation and all that I do and what I do. And then they were so nice that they give me an honorific Top Gun trofeo. I have it. I have it in my office, and also a wonderful cake. This was so tasty. I could not imagine when I saw this. I didn't want to break it, but believe me, this is also very, very nice. So allow me just to say one reference to my favorite poet, Spanish poet, Antonio Machado, not any longer there. But he says something that always accompany me and touch me, is traveler, there is no path. The path is made by walking. So thank you very much. I hope it was okay. Yeah, so I didn't let too much time for questions, but feel free to also talk to me later on if you prefer to walk and leave the room already. Anybody has questions?
I do. We can clarify that later. But I was wondering, you were showing this hotline, and do you have the 24/7 hotline for all the laser terminals?
We used to have.
This.
We used to have, and actually it was really demanding. We did it for 3 years. But the Betriebsrat helped me. No, seriously. Yes, we offer this is possible. There is the possibility to Rufbereitschaft, so in German, and we had a pool of 32 engineers that they were doing the job. Actually, we try. It was voluntarily. I mean, of course, they are paid for, but basically, it was never imposed. But yes, it's feasible. But we don't offer. Honestly, one thing that we did it at the beginning because with EDRS, I mean, every minute that they were basically not transmitting data is money. It's a business case. So they are for the beginning, but the learning curve of the operators and everybody on board on the mission control, for example, in GSOC, which they anyway have to do because they have the Bartolomeo platform, they are with the international station, they have to be there for the astronauts. So they were doing this, so the learning curve it make it possible. But it is not right now. It's not necessary 24/7.
I'm relieved. Thank you very much for this amazing talk. That was wonderful. Thank you.
Thanks to you for having me. Wait, this is going to be difficult. It's Tom.
Now, I'm a student and very much interested. You fired me up. I'm all for LaserCom. How do I get in contact with it? How do I get in contact with TESAT?
You can write me an email. No, actually, our website, I think it is, we have many things, but I will also encourage you to go to the ESA website. There is a lot of reference to TESAT and to many projects where we are, but definitely, yes, our website, www.tesat.de.
And of course, the faculty here, IRS Institute, is in contact with TESAT. So
always. I highly appreciate it. I highly appreciate the connection that we have and the bridge that is actually working very, very successful. I have to say that the flight laptop, it was really a footprint also for the capacities. I mean, this is actually, from the commanding, from everything. So really, really amazing. Yeah.
Thank you.
Yeah. One short question. Your system is limited to 80,000 kilometers by the 135 laser version. How do you communicate above? Is this radio frequency, or how do you?
More than 80,000 kilometers.
More than 80,000 with your system.
It's not possible. It's not like at the RF where you send the wave and it is done. No,
and what is the communication above this to the other satellites, which are or communication?
Deep space. Yeah, it is RF still. You need to have always the two terminals, so there is nothing beyond the 80,000, so you cannot communicate it from there towards the Earth. Yes, but as soon as you go into this is true. This is the reason that the hybrid, the combination for each layer, the best option, and this is what it has to come, and this is the network that has to be deployed. Yeah, but it's true. This is a limitation.
Okay.
There is also scientific role. like for example, the Tycho mission from NASA, where ESA is contributing, and actually the TDB1 was used to verify the fine pointing for this mission. So there is lasercom for more than this distance.
Okay, thank you.
Thank you. Tom is program manager in my team. This is
Okay. I don't know how to.
Thank you very much for amazing talk. So I was curious about the technique behind this QKD instrument that you actually demonstrated. Is it like based on single photon emission detection?
I think I can put you in contact with the core, with the source. So better I can give you the name of my colleagues, or even put you in contact if you wanted to know more about it. It is to go in detail, I cannot say right now. And also I don't know how much we can say. Sorry for that, but I think the best is that I put you in contact with them. This is how you can get the right answer probably. Very good question. It's a challenge. It's a challenge, and actually, I would say even configuration management, because it is true that every release has also new features, and if you come in with a customer, but we try to stabilize the product. I mean, actually, this is the what means to have a product. So there is also some times where it's not possible to accommodate every need. So you will not need to modify this. But for example, when we have an anomaly. I mean, anything that you have in orbit, you can only solve it having either a change in parameter, so you optimize what you are doing, or to do a new software development for solving this problem. Yeah. And for example, one of the things that we have done, nearly all the satellites or all the LCTs that we are supporting have got in certain point a software update. And in this sense, it is simple, because basically you define the functionality that has to be implemented. This is tested with the rest, and then it is uploaded and do a regression test in orbit to verify that this is working. But you are right. As soon as you have, I would say, 300 terminals, if you find a bug software, it will be for all of them, because the software is stable. So at the end, you make a release, and this release is uploaded. The challenge will be how you do this upload. Will you go for a node that is distributed to all of them? Will you go individually for all of them? This is something that we still have to work on. And this is also part of the concept of this outlook. So like what is coming. And this is also one of the challenges that I would say we have to take note. Yeah.
Okay. Thank you very much.
Thanks to you.